Hold a glass of water up to the sun, and a thin band of color spills across the table. Red, orange, yellow, green, blue, violet. A rainbow, pulled out of plain white light. That ribbon is light, quietly showing you what it's made of, and how light behaves, how it travels, bends, and paints everything you see, goes further than you'd think. Begin where your eye already trusts it. Light travels in straight lines. Switch on a flashlight in a dusty room, and there it is, a clean, straight beam. Light moves in straight rays, and until something stops it, it never bends on its own. When a ray strikes a mirror, it bounces, and it bounces evenly, leaving at the very same angle it arrived. That one tidy rule is why a mirror hands you a faithful, flipped copy of the world. Every smooth surface does a little of this. The glassy calm of a lake, a polished spoon, a dark window at night, each throws light back to your eye, which is the only reason you see anything at all. But light doesn't always bounce off. Watch what happens when it passes into something clear. Stand a straw in a glass of water and it looks broken, snapped right at the surface. The straw is perfectly fine. It's the light coming from it that bends as it crosses from water into air. Light bends because it changes speed. It travels a touch slower through glass or water than through air, and at the boundary that change of pace swings the ray to a new angle. We call it refraction. Shape a piece of glass just right, and you can steer that bending. A lens gathers a spray of rays and brings them to a single point, a focus. A magnifying glass, a camera, a telescope, your own eye, every one of them is bent light, brought to a point. Now go back to that rainbow, because it's hiding the deepest clue of all. White light is every color mixed at once, and each color bends by a slightly different amount, so a prism fans them out into a rainbow. Color is really wavelength. Red is a long, slow wave, and violet, a short, quick one. And the colors you can see are only a thin sliver of a vast spectrum: radio and infrared below red, ultraviolet and X-rays above violet, all the very same thing at different wavelengths. Look closer still and light turns strange. It ripples like a wave, yet arrives in tiny packets called photons, somehow both at once. So the rainbow in your glass held the whole story in miniature: light running straight, bending as it slows, splitting by wavelength, and underneath it all, both wave and particle. The same everyday light that lets you see, quietly carrying the fastest speed there is.